Okay, so what we're trying to do here is figure out how to interpret a Minitab output for linear regression. So here's our example. An educator wants to determine whether students' exam scores were related to revision time. For example, as students spent more time revising, did their exam score also increase? A positive relationship, or did the opposite happen? So the first thing we need to know is that our explanatory variable, which is the x, in this case is revision time. And our response variable, which is the y, is equal to the exam score. When you look at the Minitab output, right under predictor, you have here revision time. This value is always your x value. The number next to it, where you have the coefficients, this number next to your x value is always your slope. So in this case, we know that the slope of our regression line is 0.555. This value, where it says constant, is always equal to your y-intercept. So in this case, A is equal to 44.5. Now, if you were paying attention, you'll notice I originally wrote slope as m, and then I remembered, oh, wait a minute, we're in statistics class. So that means slope is b, y-intercept is a. So what's the equation of my regression line? The equation is y. Now remember, I need a caret over this, so I'm going to go insert math type equation, and I need a y hat here. So I'm going to put y, and if I come up right here, I just find the little one with a caret over it. I've got y hat. I'm going to cut and paste this. Okay, put this in here. Command V. I don't like this new math type because it puts things in random places. But so what do I have? I've got y hat. Now, this is doing weird things for me. Y hat is equal to A plus BX. So that's the equation of my regression line. What else does this output tell us? Well, if you notice, it tells me r squared right here. We're going to ignore r squared adjusted. That's taking into account other variables that we're not looking at. So I know that r squared, and so again, let me just insert math type equation because I want to make sure I have this written nicely for you. R squared, okay, is equal to 72 or 0.728. Okay, so how do I get r? Well, to get r, I just need the square root of that. Okay, so r is going to just simply equal to the square root of that. Remember, r squared is my coefficient of determination. So what do I know? I know that 72.8% of the variation in exam score can be explained by the line of regression on revision time. So that's how I interpret it. R is my correlation coefficient, and again, R is just the square root of that. So if I insert this, R is equal to the square root of, what is it, 0.728. If I pull up my little calculator here to see what that's equal to, calculator, and I do, I can't do the square root on this one. Well, you have to do it on your own. That's what R is equal to. You can do that on your own. I don't have my calculator here. Okay, now there's some other things that you see, some standard errors. We'll be looking at that later, so don't worry about that right now. Don't worry about T, don't worry about P. But the one other thing you should look at is your prediction error. So remember, S here is equal to your prediction error. And what's that equal to? That's the standard deviation of the residuals. The residuals, remember, are y minus y hat. Okay, y minus y hat is what a residual is. Okay, so our prediction error here is 6.354. What does that mean? That means that when we use the line of regression to predict exam score based on revision time, we expect to be off by an average of plus or minus, what is that? Option, nope, I don't remember what it was. Maybe shift option, let's see if I can remember the shift option, plus or minus 6.354 points. So again, everything that we need is right here. Predictor, I've got my constant, my x variable. The number next to my constant is the y-intercept. Number next to revision time is slope. R squared is my coefficient of determination. R is simply the square root of that. That's the correlation coefficient. S is your prediction error. All right.